Okay, so y equals sine of theta minus c plus d. And that's the way we always show it, theta minus c. If you have a plus in there, then if it's given that way, you have to correspond to get the correct c value, right? So if we start with y equals sine theta and replace with theta minus c, replace y with y minus d in transformation form, that's what we get. Oh, no, that's not what we get. That's what we get. Then we solve for y. There's nothing we can do with the c. It has to stay, but d, we can bring to the right. And so when it's solved for y, that means we could graph it in our calculator. Okay, so this is a horizontal translation of c units and the vertical translation of d. And then depending on what sign, SIGN of c and d, that tells us whether we can go up or down. So if c is negative, then in here, say c is negative 3. So that would be theta minus negative 3, which is theta plus 3. Anytime you have the variable plus a number, okay, then you're moving left. Makes sense that c is negative, so we're moving left. C is greater than 0, then you're moving right. Now, a word that we sometimes use, more so in physics, for horizontal translations, is phase shift. Okay? And really, that's because you're moving that whole cycle, that whole phase, left or right. So you're shifting it. Okay? Then d is less than 0, then we're translating down. If d is greater than 0, we're translating up. And these, again, more so in physics, but we call it a vertical displacement. We still are going to, when we describe the transformation, use stretch by a factor of whatever, horizontal, vertical translation, left or right. Okay? But, so the phase shift and vertical displacement might be given to us, okay, and we can do work with that, but we're not going to really use that in describing our transformations. Okay, so again, we're going to cross out the features that do not change when we do those transformations, and then circle the ones that will change. So, think about this. You're just moving the graph. Left or right, up or down. Does it change the size of it? No. Okay? So the amplitude is not going to change. The period is not going to change. This is a vertical change to the shape. This is a horizontal change to the shape. Midline, though, will change. That's going to move it up or down. So that's going to change. Domain is not going to change just because of the fact that we're starting with all real numbers, right? That's not going to change. Okay, what about the range? Yes. Because you're going to move the midline, the amplitude stays the same, but it's just going to shift everything up. So yes, that will change. What about the theta intercepts? Yep, that's going to change. And the y-intercept? Yeah. Okay. So lots of things will change with translation. Okay, if you're asked for the median value, that is d. Okay? It can be positive, it can be negative, whatever d is. That's your median value. And the equation of the midline is y equals d. Remember, a horizontal line is always y equals. So whatever that d value is, because on the base graph, it's the x-axis, y equals 0. Now you're moving everything up in units, so that midline's going to change. You have equation y equals 0. Okay, so now we're going to do a graph of y equals sine theta minus pi over 6 plus 3. Maybe we'll graph it. I'll just change this here. Graph it and then fill in the chart. Oh, sorry. It was on here. Okay, I'm going to go back and okay. All right, so we'll go back and fill that in. Here's your base graph. We've done that for you. Now you're going to have to kind of realize that that's not always going to be given to you. In any case, we're moving to the right pi over 6 and up 3. So what I suggest, what I like to do, is draw my new midline right away. So that's going to be y equals 3. So, and I'm going to do it in red. Okay, so 1, 2, 3. Okay. So if all that happened was plus 3, then I just copy out this graph starting from here. Everything would be the same except just translated up. Okay. So my normal, based on this, because we're going to get into some harder ones that have a lot of things done, transformed on it. There's no amplitude change, there's no p value, so really from here, my graph would go up and to the right from that midline and y-axis. Now, I want to go to the right pi over 6. Take a look at your graph paper, or your grid line, first of all. See what it's cut into. So every pi is divided into 6 parts. So that's helpful for us, especially with the translation of pi over 6. So, in graph line in green, this normal will now be 1 grid marking to the right. Okay? This maximum, I need to move 1 grid line to the right. This midline, meeting the midline here, 1 grid line to the right. This minimum, 1 grid line to the right. This midline, 1 grid line to the right. Okay, I'm just going to do 1 cycle for right now. Okay, so you can do more, but I'm just going to keep it like that. Okay, just try to save time a little bit. Okay, so all that's happened is shifted to the right and up. Okay, and I find it easier to do that midline and then graph from there. Okay, so for your base graph, which is in red there, hold on one sec here. Your base graph, the equation of the midline is y equals 0, it's the x-axis. Okay, remember the range is from -1 to +1. Maybe I'll do interval just to save a bit of time. Remember your theta intercepts are multiples of pi. And the y-intercept is 0. Okay? So now, equation of the midline is y equals 3. The range, you can look at your graph, okay? It's from 2 to 4. Okay? From the equation, you don't need the graph. You don't have to graph it on your calculator. It's your midline plus the amplitude will give you your max. Your midline minus the amplitude will give you your min. Okay? So sometimes we'll give you an equation, we'll put some parameters in there so that you can actually graph it, so that you can see that you know that all you have to do is take the d value, add the amplitude to get the max, d value minus the amplitude to get the min. Okay? Are there any theta intercepts? No, you've translated that so far that that green graph does not cross the theta axis. Okay? Y-intercept, well, can't tell exactly. But what's the value of theta at a y-intercept? 0. So let's try it out. Notice how it's a bigger box. That's the reason. So y equals sine of 0 minus pi over 6 plus 3. So negative pi over 6, that's a special angle. That's in the 4th quadrant with a reference angle of pi over 6. Sine is negative there. That's a small angle. So that's negative a half. So this is going to be 5 over 2. You take a look at it, that's 2.5. Kind of looks pretty close to that, right? So I know that they haven't messed up too much in my graph. Okay. So that's horizontal and vertical translations. Now we're going to put these all together. So part B. First question is basically describe the transformation. That's what we've done in transformation unit, right? We learned it, then we used it with radicals and rationals, and now, okay? So you look for your stretches. Notice the notation here. If you see sine 2 bracket theta minus pi over 4, that's all with the sign, right? It's like having big brackets there. So sometimes you'll see the big brackets, sometimes you won't. It does not mean sine of 2 times theta minus pi over 4. Okay, so context is important. It really means that. Sometimes we put the bracket, sometimes we don't. Okay? In any case, your stretches, we've got a vertical stretch by a factor of 4 about the x-axis. We've got a horizontal stretch by a factor of, so that 2 in front, remember you take the reciprocal. It's like any transformation. By a factor of a half about the y-axis. The negative out front there means a reflection in the x-axis. Oh, can I use x here? Theta. Okay. And then horizontal translation, pi over 4 right, vertical translation, 1 up. Because it's been factored, right? If it wasn't factored, you need to factor out that 2. Okay. So without graphing it, let's come up with some of the properties. So amplitude, that's your A value, but the absolute value of it. Amplitude is never negative. You'll get it wrong if you put negative. Okay, so it's 4. If this is factored, which it is, then your phase shift is pi over 4. Okay, so theta minus, so your C is pi over 4. You can just leave it like that. That's a positive value, so that means you're moving right. You don't have, for a phase shift, you don't have to put the direction. Okay, the sign will tell you, SIG. Vertical displacement is 1. Again, same deal. 1 means it's going to be up 1. Domain for all for all sinusoidal, like cosine and sine graphs, is all real numbers. So we use theta, element of the set of reals. I'm going to leave the y-intercept for now. Period. Remember we talked about this when we did stretches last week. So the normal period for sine is 2 pi. Now, so this period will be 2 pi divided by the b value. Okay. So b is 2 pi divided by the period. The period is 2 pi divided by b. In this case, b is 2. So in this case, it's going to be 5. Okay. Equation of the midline. That's y equals that d value. If you just put 1, you'll get it wrong. 1 equation. So then the range, this is where, so I'll do step builder just to show both the last page I did interval notation. So remember, think about it. This is your midline, y equals 1. Your amplitude is 4. So 1 plus 4 gets you your max. 1 minus 4 gets you your mid. So 1 plus 4 is 5. 1 minus 4 is negative 3. Okay. Don't do it the other way around. Don't go amplitude 4 minus 1. That would be 3. Or sometimes you do that. Sometimes you switch the order. Y-intercept is when theta is 0. So y equals negative 4, sine of 2, 0 minus pi over 4, plus 1. So what does this simplify to? That's going to be negative pi over 4 times 2 is negative pi over 2. Okay, that's a special angle. Negative pi over 2 is here. So from here to here. Okay. Actually, I guess it's not going from here to there. It's coterminal to that. So from here to here, that's your negative pi over 2. So that point on the unit circle is 0, negative 1. So your sine of negative pi over 2 is negative 1. So your y-intercept is 5. Yep.
If it was theta plus pi over 4, then so negative?
Yes. Yes. Absolutely. And then for phase shift. If it said what are the translations, you can say left pi over 4. So you use those positive is up or to the right, negative is down or to the left.
Yeah, it's just, so it's based, because it's just another word for horizontal translation, but.
Yeah. All right? Those properties, it's not going to affect. It's going to show in bracket. Yeah, but none of those properties is built into it in here. Okay, so now we're going to graph this. Okay, so just like radicals, for example, we can take every point on the original and do all the transformations. Okay, so let's do that for a couple of points, but we want to try to be able to graph these a little bit faster. So let's do that for a couple. For example, this point here, obviously the origin. Okay, we are stretching by 4 vertically, it doesn't change it. Reflecting doesn't change it as well, right? So this and this is not going to change 0, 0. What changes it will be the translation. Take a look at your grid markings. So this is 6 grid markings in pi. So each one of these is pi over 6. Okay, but I have to go pi over 4. Where fractions come in. Well, you need to divide this into 4 parts, right? So really, every 1.5, every 1.5 grid marking is a quarter. I don't know what I pressed there. Is a quarter of pi, right? So I have to move this point to the right, pi over 4, and up 1. Okay. Then let's do it for this point here. So that's a maximum, right? So now that y value is 1. I stretch it, becomes 4. Horizontally stretched, it's going to be half, right? So half of pi is pi over 4. Okay, then reflect it is -4. Okay, then to the right, pi over 4, and up 1. Is that kind of confusing to do all of those things? Yeah. Okay. You don't want to have to do all of those things, Sally.
So is it exactly in the middle, or is it a little to the right?
Well, I was standing to the left, so it should be right in the middle of this.
Oh, I need a second.
It should be right there. Pi over 2. Okay, so that's kind of hard to do every point. You're going to be spending a long time. Now, granted, we gave you this, you have your calculator, you can find points, whatever. So, what I suggest you do is think about, like what we did for a parabola, we found the vertex. Based on the size of it, we graphed it from there, based on the stretches. All right. This I stretch by half, which is there, and then you go back pi over 4. Yeah. So based on what we did for parabola or radical, we found a new vertex first. We actually did the translation from that. Basically, in our head, we did what the graph looks like based on the stretches and did it from there. So that's what we want to do with these. We want to graph the midline. Okay? So I'm going to actually just erase those. Kind of remember where they are. I'm going to graph my midline, which is now at y equals 1. Okay? And maybe I'll change it to red here just so you can see it a bit better. Okay. Okay, so if all we did was stretches and a vertical translation, not a horizontal, and no reflections, we'd be going up and to the right, right? That goes up and to the right from the midline and the y-axis. But we have other stuff, okay? This is nice because it is at the origin, okay? That, though, is going to move right pi over 4, okay? So pi over 4 will end up being here, okay? I'm going to erase that actually. So this point now goes to this, okay? What did we say the period of this graph is? Pi, right? So that means that this point here, pi units later, has to be the same. Okay? We have to get a complete cycle in there. Okay? What did we say the range was? We said the range was from negative 3, so from here to positive 5. Okay? So you could even put little pencil marks to know that you're never going to go above that or below that. You have to get a complete cycle in here. Okay, so halfway in between this point and this point is plot across the midline. Okay, now is that graph going to go up and to the right, like our base graph, or is it going to go down and to the right? Down, it's been reflected. So now halfway in between gets me a valley. Halfway in between gets me a mountain. And now I've got a complete cycle. I can do another one, pi units that way, halfway in between, it crosses, halfway in between the valley, halfway in between it's the max, or a mountain. Okay, then back over here, halfway, there, this is going to be up here. So you don't actually have to transform every point. If you do, it's going to take you a long time. You use your midline first. You have to know what sign looks like to begin with. Does it start at the origin? Okay, yes. Then you think about, okay, my period, because it's got to repeat. So if the period is pi, from that translated over part, it's going to be pi every time. And then it's not symmetrical, but it's divided into 4 parts really. The down part, the up part of the valley, the up part and the down part of the mountain. Okay? So 4 parts that you can divide that pi unit into. So it's going to take some practice. That's why we gave you quite a few over the next couple of days, so that you get into that practice. Okay? And if we were to ask you a graph, often we ask you for one graphing one that you have to do, even though you can punch it into your calculator. More often we'll give you a transformed graph and ask you to come up with the equation for it. Or give it bunch of properties. Okay, but you would do probably 2 cycles, so you can at least see the graph. I'm going to do all this. That stays. Okay. Next one. What's wrong? Well, not wrong, but what do we need to do in order to really know all the transformations of this particular one? Right? Exactly. We want to factor out the 3. So underneath maybe. And again, you can use big brackets, so you can just factor out the 3. then you can really tell what all the transformations are. Okay, so you go through the properties. The leading coefficient is positive, so it is the amplitude. Now this is theta plus 2 pi over 3, so I'm going to say the phase shift is negative 2 pi over 3. That corresponds to going left. Vertical displacement, negative 5. Domain is all real numbers. I'll leave the y-intercept for right now. Period, 2 pi divided by 3. Equation of the midline. And then the range. So the midline has now been moved down to negative 5. Okay, so negative 5, and then our amplitude is 1/2. So negative 5 plus 1, I'll put it and then I'll simplify it. Negative 5 plus 1/2 and negative 5 minus 1/2. So simplify that. So that's going to be negative 11 over 2 and negative 9 over 2. Oh, I don't know why all of these are there. And y-intercept is when theta is 0. You can put it back into the beginning if you want. Sometimes that's easier. Okay. So, pose the 2 pi is here. Okay, on the unit circle. So that has 1 at 1, 0. So the post is 1. So 1/2 minus 5 is negative 9 over 2. So that really means, if you take a look at your range, the maximum value is negative 9 over 2, and that's a y-intercept. This will happen. Okay, so now general cases for y equals a sine of b, bracket theta minus b, or cos. Basically all the transformations, the sine and cos. Doesn't matter if it's sine or cos, the amplitude is the absolute value of a. Phase shift is c. Right? If c is positive, it's to the right. If c is negative, it's to the left. Vertical displacement is d. Same deal. Positive is up, negative is down. Equation of the midline, y is equal to d. Then it's 2 pi over b. Or if it was in degrees, remember it would be 360 over b. Sometimes we'll be saying that degrees. The mean is always all real numbers, and then the range add the amplitude, which is the absolute value of A. The lowest or minimum value, you take your D value and you subtract the amplitude, which is the absolute value of A. Okay, so those 4 questions there I'm going to leave. They're exercises for you to do. Okay, and then we're going to get into, again, the next note sheet, which is the same deal. Putting all the transformations together, coming up with the properties and equations.